Before going into the software, I just want to recap some PowerPoint slides and go through just issues that have been seen in pharmaceutical development. Classic issues such as history of impurity tracking, challenges faced in drug development, and QBD impact, and really impediments seen in QBD and what's occurred in the lab and how much more data is seen through that. From there, software challenges. Where's all the information being collected? Where's the data abstraction occurring? Lastly, going through the software live and also a Q&A session. Now, this is a non-digital interpretation of analytical data. You'll see that there's just a spectra here with peaks and they're circled and they're assigned to specific functional groups to elucidate a possible compound. Now from there, if you look at the left-hand side, you now have a chromatogram and you start to see the disconnect that you have a spectra, a chromatogram, and within the chromatogram, you may not be interested in the APR or the intermediate product. You may be interested in specific impurities at specific threshold levels and really follow that through to have a control strategy. Down below that chromatogram, you will start using Excel. And again, you'll note we have a spectra, a chromatogram, and using Excel to really create these control strategies. So to have the whole synthetic route and really look at all impurities that we put into the synthetic route, all in silico predictions seen in one place. And from there, within this Excel sheet, you may even have, not just impurities, but solvents, reagents, catalysts to look at elemental impurities as well. Now, going back in the right-hand side, you'll see a schematic of Excel spreadsheets, and this is where people have been doing in different parts of just in Excel, just not only having your control strategies, but maybe having a validated Excel sheet to put in your impurity threshold in one place. Now, finally, things that we've seen is that by having this disconnect, users start not using their chemical drawing packages. So you're not using ChemSketch or ChemDraw or ISIS. You start putting all this information within the same Excel sheet. So in this case, it's a 2 to 3 step reaction all the way to the API product. And what users would do is really place all the impurities per stage down below with maybe the registration number, comments, in silico predictions. But that always answers and raises the question, how are you searching any of this? If you're using Excel, do you have one Excel sheet? Is it 1A, 1B, 2D? Who analyzed this? Now, again, we're taking a simple case. You may have a spectra here, you have a chromatogram, but how is it done? Where is it being collected? Where are you storing this information? And an interpretation, again, are you using a CDS system for your chromatogram, or what are you using for your high-res data? Who's seeing this? Where is this being placed? And that became crucial questions on really building Luminata through ACDLabs. Now, from there, quality by design has had a great impact on process development, specifically in establishing acceptable quality target product profiling. And this is crucial to identifying all types of impurities or your critical quality attributes. And from there, really having risk assessments to have a robust process to create those control strategies. Now, the big thing to get out of this slide is you're obtaining more data. So by obtaining more data, how are you analyzing this? And again, interpreting, where are you storing it? Now, impediments to QBDs come up within respect to analytical data. Labs have various instruments and vendors, and along with different techniques and formats. And the decision to translate data to decision is a challenge here. And this is just a survey that we did several years back, and just talking to people at Pittcon and going through how many instruments types, what vendors, what software packages are you using? And we started to notice that issue. We also heard from our clients that they encountered further impediments regarding their interpretations. So if you look at the slide, on the right-hand side, you may be interpreting 3 different ways. So you're using the software system, maybe you're putting in a notebook, internal reporting, having in Word, PowerPoint, PDFs. From there, how are you sharing this with sharing your knowledge with colleagues? Are you using paper documents? Are you having a conversation? Are you emailing them? Are you just talking to them over the phone? Are they just placed as images? And finally, what we found is most likely this information is all being stored and residing in a silo. And truly, this has become a greater issue for every user within Pharm Dev. So in this case, this is just a slide on the stakeholders' impact. So for projects, you'll have increased project timelines. In the case here for our webinar, we're going to talk about process chemistry, number of experiments, looking at process control justification, optimizing a process, in-process sampling, fade and purge, all that information for your impurity mapping. Now for this afternoon and also Thursday, talk about the analytical chemistry workflow as well, increased number of characterization experiments, and to develop those methods and validate them. Finally, for the characterization groups, isolating the work, more synthetic work, and also elucidating all those possible impurities. But again, for this session today, we're going to look at process chemistry specifically. Now, capabilities that must be met within QBD. We've heard from our clients that these capabilities which would be useful in managing the responsibilities to be met in QBD. And let's go through the differing users in pharmaceutical development. So if you're the project team lead, collection, aggregating all chemical and structural analytical data in one central place, enabling the scientists to search and retrieve and analyze the data. Now for the analytical framework, really ability to manage different instrument types, tools for the scientists, having a location where you're storing all this. Finally, just like I mentioned in the previous slide, process chemistry workflow, an interactive process map. So what you saw in Excel is that it's just a static image. You can't really do anything with that. Linking the chemical entities and associated analytical data. Most likely, if you're doing the process chemistry workflow and you're a process chemist, you may not have access to data. If you have a notebook, you probably have a PDF and you placed in all your chromatograms or LCMS within that record and inside the notebook, but you can't do anything with it. It's difficult to search. And really real-time management of all required data on product and process impurities. So really having all your impurity mapping and going through all the batches that you've done and just to see if anything's changed. And this is quite crucial when you start looking at process optimization. If you're doing a reaction over and over again, you want to see if there's any slight changes there. Now, that's really where Luminata was built several years back. And this is our interface for integrating data management. In the left-hand side, you have our project navigator. So within our project navigator, you have an area where you can put the project, process name, and also a hierarchy to have a batch number or a lot number. Now, within the navigation panel, you can also have differing screen forms. Noted in the previous slides, when you're using Luminata, you can use it for a whole project team. So within that project team, you can look at it through an analytical data set such as this screen form, but if you're doing more process optimization, maybe you just want to go through configurable tables or look at purge studies, and that's the capability of just having differing layouts. Central location is you have your process map, and I'll really dive through this more deeply when I show it into the software. Just like you saw in that image in Excel, we have our whole synthetic route, and down below, you have at every stage all impurities associated per stage. And again, this becomes quite crucial when you're going through this data. Now from there, anywhere that I click on any of the process map and any of the entities, I can see the reference data. Now within the reference data, I'll have all my gold standard data sets for that particular molecule, NMR, MS, IR, TGA, DSE, everything in one location. But from there as well too, I can add in my batch data for that particular stage. And that will align with, let's say, the API product with all impurities associated within that batch data data set. And again, just to reiterate, this is still live. And that's something that's crucial when you're looking at this, is that you can go back and look further and really delve deeper instead of taking in a chromatogram that's a PDF and really trying to zoom in further. That becomes quite difficult for any user in Pharm Dev. Now, finally, in the central location, your batch data tables. We have two different tables, and I'll go through it when I'm showing the software. You'll have an entity table that really looks like Excel, full configuration where customers are used to adding different columns, different headers, and placing that all together. Finally, your control chart. Now, the control chart aspect is more about batch assessment and risk assessment, and that's something that I'll cover in today's afternoon session. Now, Luminata was built on the agnostic Spectras enterprise platform. And what that allows us to do is within Spectras, we can import on the left-hand side 130 different instrument vendors and place it within Luminata. So that's a crucial thing. Just that whole capability of taking from all these differing vendors, having one location to put it in that one interface to have that control strategy. And what we found from just having that capability and building upon Luminata is that we can then link it with a third-party database or informatics system. So the capability of just placing things within Luminata and linking with your notebook, LIM system, your registration system, your registration compound name system is possible. And that's a crucial thing, having that all together in one place. And again, when you're going through and really deciphering and looking at Luminata, it fits the portion where people aren't doing this within their current systems. Just because LIMS and notebooks weren't built upon looking at control strategies, but having the capability of linking that information or that project, that process and stage to particular batches being quite crucial for our early adopters. Now, finally, a hidden thing that we never realized within the software is that once people that have adopted to the software started using it, they really reduced the amount of paper that they had to deal with in Excel. And what that meant was that if they were going in a project team meeting, let's say every 2 weeks, and having that discussion, instead of talking to the process chemist and asking what's the optimized step, or asking the analytical team, did we remove the one impurity through that one method, they started bringing the software. So having that software within the meeting really helped a lot. So taking bench to boardroom and finally data to decision has been quite crucial and useful for all team members for a project. So at this point, I'm going to go into the demonstration. Like we've mentioned, in this demonstration, we're going to specific for one type of a user in the farm dev team. So here, first thing we're going to do is we're going to create a record. So we're going to go into ChemSketch, we go into any drawing package, enter in the record, place into Luminata. From there, look at really impurity mapping within the software. The whole idea of having different control strategies and looking through, let's say, what's occurred in one batch compared to other. Now, once we go into the next workflow, we're going to go into process optimization or in-process sampling. The idea of just taking a sample and really delving deep into the 1 or 2 step reaction and going through the reaction completion, the filtrate, and the isolated product. So the whole workup procedure. And from there, we can also talk about purge studies, which would be a later focus as well. So let's go into the software. So right now within the software, you'll see this is ChemSketch. You'll note here, I just have a linear synthesis and I can place that within Luminata just by clicking on Add Record. When I'm adding the record, what the software will allow me to do is it's going to recognize any metadata fields that have been seen. So in this case, when you're looking at this linear synthesis, it'll see down below the registration number. Right away, it's going to use that and put that metadata within one of my tables, specifically my entity table. So now here, it's just adding the stages, creating that, and creating a new record within Luminata. Once in Luminata, you'll see it's been placed here. Like I've mentioned, you'll note that this is my navigation panel on the left-hand side where I can have my project and process names. Now, since I've added this record before, you'll note that whenever I click on a particular molecule, I can see my standard MS is there and my NMR is there as well too. So that information is already being stored there. Now, in this case for the webinar, I really want to focus on a differing screen form, so maybe more of a process screen form. So you'll note we can have differing screen forms where you can show the data. In this case, I'm hiding that. Maybe I'm not interested in that at this point, but what I am interested in seeing is, let's say, the impurity mapping. Now, really, before going through that, what's nice about the software is that you saw that when I was in ChemSketch, that I had something over the arrow. Now, again, if you're using any type of drawing package, everyone places reagents, reactants above or below arrows. But that was always an issue, just translation with any software, is actually to recognize where it goes. So in this case, I've defaulted it as a reagent. But what's nice here within the software is that I can also change how it appears within my map. So in this case, I can just select this molecule where it says the compound class is the reagent. I can change that to starting material. And once I do that, you'll see that it pops up down below. So it has the intelligence, and really that's quite crucial when you have something very complex as your synthesis or your synthetic GMP synthesis route for your API or intermediate products, is that you can place that let's say above the arrow, below, or if you wanted to, you can put it within the stage as well. Now, here we're going to go to a fully finished process. And a fully finished process will just show you the whole impurities and all the control strategies. So just to define everything for everyone that hasn't seen the software yet, the first row is my synthetic route. Anytime you see a black arrow, it shows you that that's just a synthesis. You'll note there's different colors within my molecules. If I have blue, it's my starting material, green is my intermediate and API products, and down below in every stage are light orange, which are my impurities. Now, again, this is all customizable to the user, and if you had specific needs, such as putting a specified impurity color or genotoxic impurity color, you can do that as well. What's nice here is this is still dynamic. And what I mean by that is that what the software will do for an impurity mapping, especially for a process chemist, since this is still live, I can actually show the whole impurity fate. So in this case, you'll note that I can take from the starting material, and I notice that in stage 2 that starting material has now become an impurity, so we never really removed it. And what we can do here is we can click and drag from the starting material to the impurity and create an arrow. So if it's direct carryover, you'll see a blue arrow. Now you'll note here that if you see a green arrow, and let's say that impurity now has gone through a chemical reaction and is seen as an intended conversion, and you see a green arrow. So again, specializing and seeing the coloration at every stage of the impurity fate. At this point, I just want to talk about the entity table. You saw me make that change in the compound class a little earlier. Like I mentioned, the entity table is very similar to just using an Excel. So you can configure that and really add your information. Just like Excel, you can filter down what's in your table and see the results. And in this case, I can click on a cell and I can go, well, I want to filter content by. When I filter that content by, I can just specifically look at my impurities. When I do that and I click OK, my whole table now shifts down and you'll see a funnel where the compound class is all my impurities. And that becomes quite crucial. But unlike Excel, this is still dynamically mapped to the process map. So some users don't like to see in a tabular view, and that was some of the strengths that we saw from people that are using our software currently. They may want to see it in the process map. So if in the process map, I can click on the funnel here. And just by doing that, I can see all my associated impurities at every stage. So the capability of linking a table with the visualization aspect of all molecules can be done here. Now that's just one way. And really, that's a crucial way if you're doing a 10 to 15 step reaction, and it's really difficult to see it per stage. But we also found from other users when they started using this capability, maybe they weren't interested at every stage and every level, but they were interested in maybe one genotoxic impurity and really seeing where it gets purged out. So you'll note that I zoomed in further again. And in this case, I'm just going to click on this entity right here. And just by clicking it, I can say show impurity fate. And that's really a crucial aspect of doing your workflow, is that you can hide everything at this point. So when I click show impurity fate, look, my reactions disappeared, every other impurity has disappeared, but I can really see where it started and where it ended. And what's nice about this, if there was any type of mistake, if I said, well, it didn't really come from stage 1 or stage 2, I can go back and I can remove those arrows as well. So if I disconnect that, so I can disconnect. And I do the same thing, show the impurity fate. I can see where and those changes has been done. So again, dynamically to look at those impurities, and specifically if you're looking at those mutagenic impurities and you're trying to get all your information, really see how it's being done. That's really the nice part of just going through that workflow within the software. So here, we've talked about looking at a gene-protein synthesis, looking at really impurity fates. The next portion is really focused on really going through in-process sampling. So right now we're going to go to a new record. You'll note here this is the final product is sulfobenzaimide. It's an antibacterial substance and it's really synthesized through a two-step reaction. Within Luminata, this two-step reaction can be further documented with all stages involved. And what's nice about this is, in this case, we're taking the carboxylic acid, which is in stage 1, and we're reacting it with CDI to first really creating the methyl ester for our activation to do the next step. And by doing this in the software, it's right now one step. but it allows me in the software to do in-process sampling where I can add predecessor stages or successor stages. So in this case, I'm going to add a predecessor stage. Within this predecessor stage, I can name it to whatever compound class I want to call it, and it adds it down below. Now, here, again, this map is still dynamic and we can still move things around. So I can really generate how the in-process sampling would look. So I can just move this stage over, maybe even use some functionality to just create a elbow arrow. And at this point, I want to put in my molecule, which is the methyl ester, and I can just take that molecule that's been drawn before and place it here. So once I have that information, I can paste it within this stage. Now, once that's done and we've activated this, then we can add the next substance. And within that, you see that I just changed my record and I showed the next substance. So from here, we have our carboxylic acid going to our methyl ester, really reacting to the next stage and creating the reaction completion step. Now, if you are doing these portions right now, currently, this is quite difficult to just obtain all your knowledge. So if, let's say, using an example that I've seen from other pharmaceutical companies that I've talked to, is that if you're doing this workflow, you may have put in a record inside an ELN, but at that point, you can't really easily link it, let's say, to a specific stage or a specific step. And if you do, you're putting a PDF. So let's go through and look at this activation portion right here. If I have access and my colleagues have, let's say they're using Empower, they're using Chromeleon, they can have the capability of exporting that out inside of a Spectras processor format, and I can place that within this one in-process record. So I can get an idea of what it looks like with raw data and actually process data here. So in this case, let's look at the example for your methyl ester. I can go within processor. Within processor, I already have the file open, and I can actually update that in that particular stage. So I can just update database, put it to the stage of activation, and now when I do that, choose the relative amount. What's nice about this is that it's taking in the area percents from the instrument and also the RRT values. So you're not reprocessing, you're taking all the information that's already been done by other colleague and you're just importing to that specific stage of interest. And once I do that, it will appear inside of that record. So you note that. In this case, I have my methyl ester, and really down below, I have my impurity, and you'll see it just has a retention time. So I don't need to have all the molecules there too. But what I want to do is I want to see actively what's occurring within my in-process steps. Now, finally, to really complete the workup here, you'll note that we just stopped reaction for reaction completion. But instead of adding predecessor stages, I can add successor stages. So in this case, I can add, and just say a child, and really get to the isolated product stage. And that's crucial here. I can get to the isolated product and just take that molecule and place that down below as well too. And once I put that in, from there, I can also have my filtrate. So if you look now inside of my map, I've gone and I've actually gone through the whole workup from the very beginning to where we reacted it to go through the reaction completion and looking through the filtrate and what's come out, and also let's say if we did a workup with just recrystallization, so isolated product, and from there, really the final map that you're looking at. So in this case, you'll note that you have your reaction completion with all the impurities associated with that step, the filtrate, what's been sifted out, let's say a little bit of products come out with some impurity that's been purged as well, and an isolated product with all the impurities as well. Now from there, just like you saw, you can map your impurities. So if I wanted to, I can take from the reaction completion and draw that. And this is quite crucial when we're talking about it this afternoon and even Thursday as well. From there, from having all these arrows from what you saw with my GMP synthesis and where you're seeing with my in-process sampling, I can start looking and really deciphering my carryover studies and my cumulative carryovers and my process optimization steps. So really going through and deciphering what needs to be done. And also within every record, you'll note, I can have my process optimizations and really discuss what's occurring within this one batch, having that information seen here. All that information being stored. And like I mentioned, this is something that's very difficult if people are doing it now. Either they have the record, it's already been pasted in, and all the, let's say, data abstraction that they've had is all static and just PDFs. no way of really searching and really going and delving deeper with that particular synthetic route that they've done. Now to summarize, really, QBD approaches to process development dramatically increase the amount of data projects generate. Luminata helps teams organize all relevant data to save time and keep projects on track. For process chemistry, the ability to store the GMP synthesis and optimize particular steps. For every project, the ability to assemble live data critical for efficient control strategy decision making. And that's the crucial part about doing this, is that you want to have that control strategy and really make sure that everything's well aligned. Now, again, I'd like to thank everyone for their time. And I hope this is very informative. And if you have any questions, please feel free to ask.